12 2nm cable with ground can be suitable for use in Liquid Tite outdoors, provided it is properly installed. The Liquid Tite offers protection against moisture, sunlight, and physical damage. Firstly, ensure the Liquid Tite is properly sealed at all openings to prevent moisture from entering. Secondly, extend the cable at least 12 inches beyond the end of the Liquid Tite to create a drip loop, which prevents water from entering the box. Thirdly, support the cable at regular intervals to prevent stress on the conductor joints. Installing a grounding rod at the post is not required by code, but it is a beneficial practice for enhancing safety. You can make the joint connection between the two ground wires inside the receptacle box. Use a listed grounding wire connector approved for the wire sizes. Crimp the connector securely using the appropriate tool. You will need to use a copper grounding wire that is at least number 8 AWG in size for the grounding rod connection. You can clamp the grounding wire to the post with a grounding clamp. Run the wire through conduit to the receptacle box and connect it to the grounding terminal using a connector. Be certain that the duplex receptacle is weather resistant for outdoor use. Use ground fault circuit interrupter protected outlets for any electrical devices near water, including the pool pump. It is crucial that all electrical work be inspected by a qualified electrician to ensure code compliance and safety. Considering the specifics of using number 12-2nm cable within Liquid Tite conduit, it is important to understand the conditions under which this installation is acceptable. NM cable, or non-metallic sheath cable, is typically designed for indoor use in dry locations. However, when installed inside Liquid Tite, also known as Liquid Tite flexible metallic conduit, it can be used in damp or wet locations, such as outdoors, provided certain precautions are taken. The primary function of the Liquid Tite is to protect the NM cable from physical damage and moisture. The conduit itself is designed to be watertight, preventing water from coming into direct contact with the cable. However, it is crucial to ensure that all connections and fittings used with the Liquid Tite are also rated for wet locations. This includes the connectors that attach the conduit to the junction box or other enclosures. These connectors must be properly sealed to prevent water ingress. When installing the NM cable inside the Liquid Tite, it is also essential to avoid overfilling the conduit. The National Electrical Code, NEC, specifies the maximum number of conductors allowed in a conduit of a given size. This is to ensure adequate space for heat dissipation and to prevent damage to the conductors during installation. Refer to the appropriate NEC tables to determine the allowable fill for 3/4-inch Liquid Tite conduit with number 12 AWG conductors. In addition to the conduit fill requirements, it is important to consider the ampacity of the number 12 AWG conductors. Ampacity refers to the maximum amount of current that a conductor can safely carry without exceeding its temperature rating. The ampacity of number 12 AWG copper conductors is typically 20 amps, but this can vary depending on the insulation type and the ambient temperature. Ensure that the circuit breaker protecting the circuit is appropriately sized for the ampacity of the conductors. In this case, a 20 amp breaker would be suitable. When transitioning from the Liquid Tite conduit to the junction box, it is good practice to create a drip loop with the NM cable. A drip loop is a bend in the cable that allows water to drip off before it enters the box. This helps to prevent water from accumulating inside the box and potentially causing a short circuit or other electrical hazards. The drip loop should extend at least 12 inches below the point where the cable enters the box. Regarding the grounding of the outdoor receptacle, installing a grounding rod at the post is a supplementary measure that can enhance safety, although it is not always required by code. The purpose of a grounding rod is to provide a low impedance path to earth for fault currents. This helps to ensure that the circuit breaker will trip quickly in the event of a ground fault, minimizing the risk of electric shock. The grounding rod should be made of copper or copper-clad steel and should be at least 8 feet long. It should be driven into the ground until at least 8 feet of the rod is in contact with the soil. The grounding wire connecting the grounding rod to the receptacle box should be at least number 8 AWG copper. This wire should be run in a continuous length, without splices, from the grounding rod to the grounding terminal in the receptacle box. The connection between the grounding wire and the grounding rod should be made with a listed grounding clamp. This clamp should be made of a material that is compatible with both the copper grounding wire and the grounding rod. When connecting the grounding wire from the grounding rod to the grounding terminal in the receptacle box, it is permissible to make a joint connection inside the box. This is typically done using a wire connector, such as a split bolt connector or a crimp connector, that is listed for grounding purposes. The wire connector should be sized appropriately for the number 8 AWG grounding wire and the smaller grounding wire from the number 12mm2nm cable. Ensure that the connection is tight and secure to provide a low impedance path for fault currents. It is also important to bond the metal enclosure of the receptacle box to the grounding system. This can be done by connecting a grounding wire from the grounding terminal in the box to a grounding screw on the enclosure. This helps to ensure that the enclosure is at the same potential as the grounding system, minimizing the risk of electric shock if someone comes into contact with the enclosure. Regarding the use of a ground fault circuit interrupter, GFCI, breaker, it is essential for protecting outdoor receptacles, especially those near water. A GFCI is a device that monitors the current flowing in a circuit and quickly trips the breaker if it detects a difference between the current flowing to and from the load. This difference in current indicates a ground fault, which can be a sign of a potential electric shock hazard. GFCI protection is required by the NEC for all outdoor receptacles, as well as for receptacles located in bathrooms, kitchens, and other areas where water is present. The GFCI breaker should be installed in the electrical panel and should be properly labeled to indicate that it protects the outdoor receptacle. Before using the outdoor receptacle, test the GFCI breaker to ensure that it is functioning properly. This can be done by pressing the test button on the breaker. If the breaker trips, it is working correctly. If it does not trip, it should be replaced. In addition to the GFCI protection, it is also important to use weather-resistant receptacles for outdoor installations. Weather-resistant receptacles are designed to withstand exposure to moisture and sunlight. They typically have a corrosion-resistant coating and are sealed to prevent water from entering the receptacle. Weather-resistant receptacles are marked with the letters WR on the face of the receptacle. When installing the receptacle, use a weatherproof cover to protect it from the elements. The cover should be designed to keep water and debris out of the receptacle when it is not in use. There are several types of weatherproof covers available, including flip-up covers and bubble covers. Choose a cover that is appropriate for the application and that provides adequate protection. Finally, it is essential to have all electrical work inspected by a qualified electrician to ensure that it complies with the NEC and local codes. An electrical inspection can help to identify potential hazards and ensure that the installation is safe and reliable. The electrician will check the wiring, grounding, and GFCI protection to ensure that they are properly installed. They will also verify that the installation complies with all applicable codes and regulations. In summary, when installing an outdoor receptacle, it is crucial to use the appropriate materials and techniques to ensure safety and code compliance. This includes using number 12mm2nm cable and Liquid Tite conduit, installing a grounding rod, using a GFCI breaker, and using weather-resistant receptacles. It is also essential to have all electrical work inspected by a qualified electrician. By following these guidelines, you can ensure that your outdoor receptacle is safe and reliable. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. Ignoring these precautions can lead to electrical shock, fire, and other hazards. It is always better to be safe than sorry when it comes to electrical work. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate safety gear, such as gloves and eye protection. If you are unsure about any aspect of the installation, consult with a qualified electrician. They can provide guidance and ensure that the work is done safely and correctly. Moreover, consider the local climate conditions. In areas with frequent heavy rainfall or snow, additional measures may be necessary to protect the electrical components from moisture. This could include using a more robust weatherproof enclosure or installing a drainage system to prevent water from accumulating around the receptacle. In coastal areas, salt air can accelerate corrosion of electrical components. In these areas, it is important to use corrosion-resistant materials and to regularly inspect the installation for signs of corrosion. If corrosion is detected, the affected component should be replaced promptly. Furthermore, ensure that the outdoor receptacle is properly located. It should be placed in an area that is accessible and convenient to use, but it should also be protected from physical damage. Avoid placing the receptacle in an area where it could be easily struck by a vehicle or other equipment. If the receptacle is located in a high-traffic area, consider installing a bollard or other protective barrier to prevent damage. Consider the load that will be connected to the outdoor receptacle. If the receptacle will be used to power heavy-duty equipment, such as a pool pump, ensure that the circuit is adequately sized to handle the load. The circuit breaker should be rated for the appropriate amperage, and the wiring should be of sufficient gauge to prevent overheating. If you are unsure about the load requirements, consult with a qualified electrician. Finally, remember that electrical codes and regulations are constantly evolving. It is important to stay up to date on the latest requirements to ensure that your electrical installation is in compliance. Consult with your local building department or a qualified electrician to learn about the specific requirements in your area.